Hello everyone and welcome to your Chem 113 review on the Introduction to Acids and Bases. My name is Jason and I work for the ASU Tutoring Centers. Now we're not going to get too in-depth on acid and base chemistry. That is for a different video. I believe that is covered more in Chem 116 or Chem 2 rather than Chem 1. But here we're just going to give you a very general idea on what an acid and a base is. There are different types of acids, as in like there are different ways to define an acid. There's like a Lewis acid, an Arrhenius acid, a Bronsted-Lowry acid. But we are not going to get into those specifics. Again, we're just going to give the general idea of what an acid is. So an acid, we can think of as essentially being, it's an ionic compound that form hydrogen ions in aqueous solution. So essentially it's ionic compound with hydrogen cation. So if your cation is hydrogen, essentially you're an acid. That's the very general way of thinking about what an acid is. Again, there's way more specific ways of thinking about it, but that'll be for the future. Whereas a base, these are ionic compounds that react with hydrogen ions. And that's incredibly general. Typically, the bases will produce hydroxide ions. So typically, these have OH minus as the anion, sort of in contrast to the H plus that is the cation. But they don't have to. They don't have to be. There's lots of organic bases that do not have hydroxide in them. So something you'll notice, the big reason why is like the hydrogen ion and the hydroxide ion, if you were to put them together, what would you get? You would get water. So that's the essential idea, is they're the two components of water that sort of break apart. And if you have a lot of hydrogen ions, so if you have a lot of this, it's very acidic. If you have a lot of that, it's very basic. But they kind of cancel each other out. So if you were to have like a strong acid, like hydrochloric acid or sulfuric acid is the stuff in your stomach, and you were to combine that with a strong base, like sodium hydroxide, and you were to combine them just perfectly in the correct amounts, you would just get water. And there's some very like famous chemistry videos, you can look it up online, of like chemistry professors doing that in class. They take a strong acid and a strong base, they combine it, and then they drink it down because it's just water. Terrifying, but the chemistry checks out. Cool. 2, what differentiates strong acids and bases from weak acids and bases? And this is actually a discussion we've had before. Essentially, strong acids and bases are strong electrolytes, which means they dissociate completely in water. In solution, I should say. Typically, the solution is water, but they dissociate completely. So if you have a strong acid, which again, I'll just give you an example, hydrochloric acid, it's going to completely dissociate. You drop it in water, it's going to immediately become hydrogen ions and chloride ions, immediately. Whereas if you have a weak acid, like HC2H3O2, this is acetic acid, it's going to dissociate a little bit. It's going to dissociate slightly, but not necessarily all the way. So instead of using an arrow, we're going to use this like double-sided arrow, which essentially means it's in equilibrium. So this guy over here, the left-hand side, is making hydrogen ions and the acetate ions. But these two are also combining together to produce our acetic acid back. So we're in this constant state of this producing that and that producing this. And if they do it at the same rate, then we say it's in equilibrium. Because essentially you look at the beaker and it seems like nothing's changing. You still have the same amount of acetic acid, hydrogen ions, and acetate ions. But in reality, it's constantly changing. Like these hydrogen ions are constantly reforming acetic acid, whereas the acetic acid is constantly reforming the ions. So although the quantity of each species doesn't change, the actual, like if you were to observe a single hydrogen ion, you would see that it's constantly changing from these two forms. Very interesting. So that's why we use this sort of double-sided arrow when it's a weak acid or base, because it's constantly going between the two forms. Whereas with a strong acid or base, we just use a single arrow pointing to the right because it dissociates into the ions and then that's it. It doesn't come back. That's what makes it a strong acid. It goes in one direction and then stays there. Cool. Examples of common acids. There are 7 common strong acids that we highly recommend learning. They are HCl, HBr, HI, HClO3, HClO4, HNO3, and H2SO4. Okay. These come from the halogens. The halogens are the 7th group in the periodic table. So you just take hydrogen and attach it to a halogen. These are all examples of strong acids, except for if you actually look at the halogens, right? It looks like this in column group 7A. Why is fluorine not included? HF, hydrofluoric acid, is actually a weak acid, which is really weird. The reasoning for that is a bit complicated, but the idea is essentially that fluorine is really tiny, which we'll talk about in future videos, so small that that the forces holding the hydrogen and the fluorine together, because it's so small, they're really close together, the hydrogen and the fluorine. So the hydrogen and fluorine don't want to let go of each other. They don't want to dissociate because the pull between them is so strong. So because it doesn't want to dissociate, it's not a strong acid, because strong acids are really ready to dissociate. They're ready to go. So these are strong acids. As for strong bases, we recommend learning about 6 of them. And these just come from the first and second columns of the periodic table. So you have lithium hydroxide, you have sodium hydroxide, and you have potassium hydroxide. These all come from the first column. And then you have calcium hydroxide, strontium hydroxide, and barium hydroxide. And these all come from the second group of the periodic table. So those are the strong bases you would want to know. So you have strong acids, strong bases. Notice that all of these include the hydroxide. Again, it doesn't have to include hydroxide to be considered a base. But as I mentioned, most of the bases, particularly the ones you'll be working with in Chem 113, 116, include a hydroxide element to them. All right. Thank you all for watching. As I mentioned, I work for the ASU Tutoring Services. If you want more information about the free tutoring services available on all 4 major ASU campuses and online, please check out tutoring.asu.edu/content/tutor-search. If you go here, you'll be able to actually look up a tutor on any campus you're on or online and find one that can help you with your specific course. So thank you again for watching, and I hope you have a fantastic day.